In this Pechakucha, the research includes the process of creating a one-handed VR controller with an Arduino architecture. The target market of such a product are people with a keen interest in using one-handed controllers and people who are physically handicapped. The process included making sketches and creating low-fidelity prototypes that helped with the ergonomic design choices. So what are VR controllers? Well, VR controllers are a device that can be used to control the virtual world. It is usually paired with a VR headset in unison and can be used to play any conventional games or VR specialized games. Problem statement. Users who have already adapted to using conventional controller might want to use one hand to play games that don't require skill like Among Us or Fall Guys. The controller caters to a niche market of games and the controller allows physically handicapped people to play conventional games with ease. Goal statement. One of my goal statements is to create a controller that is functional but also has external components like the button and analog joystick that doesn't feel cheap compared to conventional controllers. I also have to create a case design that is ergonomic and has structural integrity that is also satisfying to play with. I had implemented the 6 Ws to understand where my target market is situated and if the solution is viable. So far, I have found two different markets to target where one are the game enthusiasts looking for a new way of gaming and physically handicapped people who lost functions in one arm. My approach to creating a better user experience. First, I discussed with my fellow gamers and my peers to design a better way of using one hand to play games, and also I also checked if this product exists in the market or if there's a market for it. I also allowed users to test out my prototype to understand better. This evolution map shows the process which I had taken to make the one-handed VR controller. One of the most important part of this process was to find a compatible Arduino chip for a reasonable price, which I was able to do at the end. But the BLE Sense has a more complexities than the Atmega which I used. Prior to the design process, I had reviewed 5 different controllers. The Xbox controllers had the best ergonomic design, whereas the PlayStation had the best software and hardware. The keyboard and mouse were more of a benchmark to see if it outperforms the market or not. And the Nintendo Switch had given me the inspiration to build a one-handed controller. By using the empathy map and having some discussions with the local gaming community in my region, I had created this persona which reflects a game enthusiast. It was easier to map it was easier to map out the design of the product by using this. I shall be improving upon this persona the further I go with my design process. Clay model and 3D printing. The first prototype that I made was constructed using clay that was bought from Kmart by squeezing it. The last two low fidelity prototypes were created using 3D printers at the WSU campus. One consideration that I had was to laser cut wood or cardboard to make the low fidelity prototypes, but it wouldn't have the best ergonomic feel. The clay model gave me the overall shape to go for in the design, whereas the 3D printed prototypes gave me a more in-depth view on what the final product could look like. I had tested the ergonomics of both before continuing with any more design iterations. I had tested the high fidelity prototype by playing the game The Forest, where my task was to cut down a tree and bring it to the spawn area. It was quite difficult at first due to its sheer size, which I have to consider next time, but other than that I was able to perform the task with relative ease. RiftCat Virtual Reality Emulator. The RiftCat was quite finicky when it came to playing games, and it only allowed me 10 minutes of gameplay per day for free users. It also had very bad refresh rate on the phone, which made for terrible gameplay. Next time I'd have to buy the full version before testing it out. After letting a different user use the one-handed VR controller, I had let them fill out a form that allowed them to share their user experience. The controller was not as comfortable as I thought it would be, and it malfunctioned at times, which is a good indication for a new iteration. The methodology I took: primary research, secondary research, and the sketches that I did were brainstorming ideas. I also did casual interviews with users for better understanding, and I made low fidelity prototypes, which were clay models and 3D printing. And by the end, I also made a high fidelity prototype, which was done by also 3D printing and implementing an Arduino chip. The pros of the controller: the controller has grooves on the side that fit the fingers, allowing for better grip. The key bindings can also be changed to anything on the keyboard. The one analog joystick can perform all tasks. The controller is also wired directly to the computer, reducing input delay. The cons of the controller: the casing is too big to wrap your hands around. The controller is also not wireless. The controller also has limited amount of buttons. The analog joystick doesn't have enough sensitivity. It also does not have a safety strap in case it falls. The connection via wire is loose and also it often comes out, but that is not the fault of the overall design, but the actual product itself. What to focus on next time: use the clay model to measure out the depth and distance of the finger placement, which I have to do next. Make more prototypes to hone in on one design choice. Add more buttons for a better gameplay, and also map the controller to a D-pad instead of the keyboard, so um, both mechanic can be functional. I also have to spend more time with the abstract designs to innovate a better way of playing games. I also have to find a better virtual reality emulator or instead buy the virtual reality setup. I also have to spend more time with the user to truly understand if the product is good or not. In conclusion, for the next design research, a more thorough data collection process has to be implemented to get a concrete evidence of the gap in the market. The new market that I'll be catering towards will be people who are physically handicapped, allowing them to play games like any other users. The casing design also has to include insertion points that keep the components anchored.